Rice on Channel 32 with Dark News Broadcast. Looks like there is yet another disaster around the world. Let's take a look. This is El Salvador. However, what you're looking at is the starting product of yet another country in danger. There was an earthquake that occurred as a result of the Caribbean and Cocos plates. Here we have geologist David Unger to explain to you how this works.
An earthquake is a sudden motion or trembling of the Earth's surface caused by the release of strain between plates. Typically, two plates try to move past each other, but frictional forces stop that movement.
Wow, how interesting. Do go on.
When the strain from the plates exceeds the frictional resistance, movement occurs. The greater the amount of strain required results in the greater amount of movement and energy released.
So I believe this is where our fault comes in, right? I know how this works. I'll explain this. So because of the strain between the plates and the movement of the plates against each other, this causes some blocks or rocks to either fracture or pull apart. Thank you, Dr. David, for explaining. In this case, fault line Abreu-Sebastian was a reverse fault, which means that the rocks got compressed together, pushing up some of the land. However, there could be different types of faults, right? Would you like to explain this, Dr. David?
Well, other than the reverse fault that you mentioned, and you can also have a normal fault and a strike-slip fault. The normal fault occurs when the two plates pull apart, causing a steep fault plane sliding down a piece of land from the rest of the land. And a strike-slip fault is when two plates literally move past each other, so instead of the usual up and down movement of the land, you get a forward and back movement.
How interesting. Thank you very much. We'll be hearing from David later on. Thank you, David. So the movement of the plates caused the earthquake Ricardo Alicitia to shake with a magnitude of 9.2, making it one of the largest recorded earthquakes ever. How exciting! However, more damage occurred as a result of this magnificent earthquake. The country of El Salvador had many stations placed in order to calculate the location of the epicenter. Here we have David again to explain how they measured the rough location of the earthquake.
Hi, so what we have here is an S&P interval. This shows us how far the earthquake epicenter is from the station. How you measure the distance is by measuring the time of the waves. The first set of waves is called the P wave, and the second set is called the S wave. What you do is take the starting time of the S wave and subtract the starting time of the P wave from it. Then you have the distance of the epicenter is located from the station.
What would we do without you, David? So we also would like to ask you, how do they measure the magnitude? I know I'm curious. I only got a script telling me that the magnitude is 9.2. However, I haven't the slightest clue just how they got this number. According to my script, this magnitude is 10 to the 4th greater than the magnitude of the earthquake that rocked St. Catharines in June. Now what on earth does that mean?
So the Richter scale measures the amount of energy released by the earthquake. And because the energy released is so great, it is much easier to use exponents when measuring it. We even simplify it further to just the exponent number. So instead of saying that this earthquake has a magnitude of 10th to the 4th, we can just say this earthquake has a magnitude of 4 on the Richter scale. And every difference of 1 point on the Richter scale indicates a 10-fold increase in energy released.
Maybe I'll use the Richter scale to measure the amount of energy released whenever I call my kids to get ready for school. I'm sure no normal scale can calculate the energy I release when I do so. Anyways, Ricardo Alicitia had a magnitude that went off the scale. You can see in the following picture where we would find that sort of magnitude on the Richter scale. The earthquake shook all areas around El Salvador. An earthquake with that sort of power would cause severe damage, and that's what Ricardo Alicitia just did. The following are some pictures of the disasters. There are a total of 600,000 casualties as a result of the tumbling buildings and broken roads. This horrific but exciting event cost the city around $3.5 billion. Unfortunately, the schools affected were not prepared for this sort of disaster and did not install any firm secure disaster plans. So most of the students who attended the school that day suffered from the shake. Not only was there an earthquake, but this earthquake triggered an eruption.
Hello again, Anne. A composite volcano, also called a stratovolcano, is created from a deep pool of magma that rises to the surface either through a central vent or multiple vents, to create a large, complex, steep-sided cone, just like the one you see here. However, a composite volcano has quiet periodic eruptions. Can you tell us more about what happened with this particular volcano, Anne?
This volcan Chaparrastique is located in the city of San Miguel, and you can find this volcano near the Caribbean plate. But this volcano isn't like other composite volcanoes, or at least it has proof so by this eruption. When this volcano erupted, it released much ash and gas that had traveled at a speed of 115 kilometers per hour. Now that's pretty fast. The ash doesn't only mummify the living, as we all know. We'll ask David to touch on the effects of the ash. David, on to you.
Well, Anne, the ash doesn't only affect the living, but if it is a large quantity, then it could be heavy enough to collapse the roofs of buildings. Did you know that sometimes the ash itself doesn't cause a death? If there's a pyroclastic flow, then the burns and the asphyxiation from the surge will most definitely result in the death. It might have not even been the ash itself. The ash, though, may carry sulfates, carbon dioxide, hydrochloric and hydrofluoric acid, so it may cause harm to your respiratory system. It also harms the environment. Habitats would be covered in ash and not suitable for living, causing animals to find somewhere else to live, or even trapping the animals and suffocating them until they die. This can cause other sorts of harm to the environment.
Wow, David, that sounds really dangerous. What should we do then if we were all to prepare?
Since the pyroclastic flow and ash are the major health threats and killers, the best thing we can do is create an emergency kit with necessities and evacuate the area. Also, having a warning system will help you evacuate in time.
Well, there you have it, folks. How to avoid dying from a pyroclastic flow. The following are pictures of the effects of the volcanic eruption. So far we have an earthquake that had a magnitude of 9.2, and now we have a volcano that spits out ash. What more disaster can come to the country of El Salvador? A tsunami, that's what. Since the earthquake's epicenter was located in the water, the force may have triggered a pyroclastic volcano, but it also forced a tsunami. Now, how did that happen? When the earthquake occurred, large sums of water were displaced, and the energy of the earthquake were transferred to the water, and then radiated in all directions at a speed of 800 miles per hour. That's really fast. The bulge of the water created was only 2 meters high, however grew to 1.4 kilometers high when it reached the shore. Talk about a killer wave. David, will you explain why the wave grew so much?
This growth occurs when the compressed water enters the shallow water. The motion of the water is slowed along the bottom of the wave by friction from the ocean bed. The crest of the wave continues to move at a rapid speed, creating a tall cresting wave.
Wow, how interesting. You truly do learn new things each day. As we look at this map, we can view the areas affected by the tsunami. The tsunami hit the east coast first, destroying San Miguel and all the surrounding areas. Then it worked its way northwest, hitting Santa Ana. Then it even reached outside of El Salvador and swept up through the city of Esquipulas. This disaster cost a total of $798 billion in damage. But there's hope, Canada. We can prepare for tsunami, and here's David again to tell you how.
To begin, your city must have evacuation routes to safe areas. Then you must be prepared to survive on your own for 3 days. So in order to do this, you must have an emergency kit. Taking a first aid course might help you, and learning survival skills is recommended. You must always be listening to the radio for any instructions on when it is safe to return to your home. If a tsunami does seem like it is coming, stay away from the beach. Do not go to the beach to watch it. Try to move to higher ground or further inland. These are the basics to surviving a tsunami.
Why, thank you, David. I'm afraid this wraps up today's session of Dark News Broadcast. Until tomorrow, Canada.